finally, we have made it to the last batch of identities in this section, the half angle identities. So first we're going to talk about what is a half angle. Well, it's basically that an angle that's been cut in half or divided by two. So if you have theta or x or whatever usually represents your angle, it's going to be divided by 2. So you might have an expression or an equation where you see something like cosine of theta divided by 2 or the tangent of x over 2 or so on. Okay, so basically your angle is being divided by 2 before you find its trigonometric function. Okay, the half angle formulas are in the box. Okay, there are 5 of them. They can look a little intimidating. If you look at the expressions on the left hand side, they all involve the angle a over 2. Okay, so you're taking the trigonometric function of some angle that's being divided by 2. And to get that trigonometric function, you're having to plug into the formula on the right hand side. And on the right side, these expressions only involve the angle A. Okay, so the stuff on the left has the angle A over 2, and then the stuff on the right has just the angle A. Okay, so I am going to read through these guys. All right, starting with equation 14, we are told that the sine of the angle A divided by 2 is equal to plus or minus the square root of the entire quantity 1 minus the cosine of A all divided by 2. And then the cosine of the angle A divided by 2 is equal to plus or minus the square root of 1 plus the cosine of A all divided by 2. And then in equation 16, we see that the tangent of the angle A divided by 2 is equal to plus or minus the square root of the quantity 1 minus the cosine of A, all divided by 1 plus the cosine of A. Equation 17 is another half angle formula for tangent. Tangent of the angle A divided by 2 is equal to 1 minus the cosine of A, all divided by the sine of A. And then lastly, in equation 18, we have a third half angle formula for tangent. The tangent of the angle A divided by 2 is equal to the sine of A, all divided by 1 plus the cosine of A. Okay, so in reference to tangent having 3 different half angle formulas, this is the one that's the most complicated. If you notice, these last two do not have the plus or minus, and they don't have the square root. So these two are preferable to use because you don't have to deal with the complicated formula. Go that route if you can. Okay. The other thing I want to mention before we get some practice here is the plus or minus. What is that all about? Okay, so if you read this note out to the side, it says, in the half angle formulas 14, 15, and 16, the plus or the minus sign is determined by the quadrant of the angle A over 2. Okay, so basically what that is saying, okay, the plus or minus is going to be determined by what's on the left side of the equation. Okay, and I'll talk more about it as we go through it, but just in a nutshell, say I had the sine of 67 degrees. Okay, that's what was on the left side of this equation. Okay, so I'd have to plug and chug into the right side, to get the value. But at the end of the day, I'm computing the sine of 67 degrees. 67 degrees is in the first quadrant, so its sign has to be positive. Okay, so whatever value I'm computing on the right side, it has to be positive because 67, like I said, is in the first quadrant, and the sign there is positive. Okay, so that's what that box is telling you. Okay, all right, I am not going to derive these. We are going to jump straight into a very popular kind of example to do with these half angle identities. We can use them to find an exact value. So in example 7, the directions will say use a half angle identity to find each exact value. And in part A, we're going to find the sine of 22.5 degrees. Okay, now the directions may not be nice and tell you, hey, use a half angle identity. So a big clue here is that you see this 0.5. 0.5 is 1/2. So if the directions did not tell you to use a half angle identity, that would be your big clue to do so. Okay, so what we're trying to do is compute the exact value of the sine of 22.5 degrees. 22.5 degrees is not on the unit circle. Okay, so we're going to have to use some kind of identity. You can't plug and chug into a calculator because that'll be a decimal. Okay, so we're going to use the half angle identity for sine. Okay, so we'll come up here. There's only one sine formula, so we're going to have to use equation 14. I'm going to go ahead and jot this down. All right, so we know that the sine of a divided by 2 is equal to plus or minus the square root of 1 minus the cosine of a, all divided by 2. Okay, that's what we will be using here. Okay, so what I'm going to do is kind of compare this to what I'm trying to find. I'm trying to compute the sine of 22.5 degrees. Okay, so I'll get to the right side in just a second. Okay, but look at this. Sine of a over 2. Okay, we have to match that up with sine of 22.5. Okay, these two guys need to match. Okay, so I'm going to come over here. A over 2 has to be 22.5 degrees. Okay, so this is going to allow me to solve for a. Okay, so if I want a, I need to multiply both sides by 2. Okay, so I'm going to multiply this side by 2, so I have to multiply this side by 2, and then over here the 2's will cancel, and so the a value that I'm going to have to plug into the formula is 22.5 times 2, that is 45 degrees. Okay, so to get the sine of 22.5 degrees, okay, we plug and chug into the right side of the identity using a equals 45 degrees. So we are going to get plus or minus the square root of 1 minus the cosine of 45 degrees over 2. Okay, so now we just need to simplify this and we will be good. Okay, we also need to pick the plus or minus. Okay, so remember what I just told you. We are computing the sine of 22.5 degrees at the end of the day. 22.5 degrees is an acute angle. It's in the first quadrant. Okay, so 22.5 degrees is in quadrant 1, so its sine will be positive. Okay, so we are going to choose the plus sign. Okay, so I'm going to go ahead and drop the plus or minus, okay, because I know my answer is going to be positive. Okay, all right, so if I continue simplifying this, I'm going to have 1 minus the cosine of 45 degrees is the square root of 2 over 2. Okay, all of that is over 2. And a drawback of doing these types of formulas is you can see you can get really complicated answers. Okay, we are going to have to simplify this in a sense. Okay, so here we go. I am going to look in the numerator and I'm going to try to get a common denominator. Okay, so if I write 1, I have 1 minus the square root of 2 over 2. I need to make these guys both fractions over 1. Okay, so 1 is 1 over 1, so we'll have 1 over 1 minus the square root of 2 over 2. Okay, all of that is over 2. Okay, and then I'm going to obviously need some more room. Okay, so I'll come over here. All right, so underneath the square root in the numerator, I'm going to get a common denominator of 2. Okay, so I need this guy to have the correct denominator, so I'm going to multiply by 2, do it to the bottom, do it to the top, so we're going to get 2. And then we're going to subtract. And then the other term already has the correct denominator, so we're just going to keep the square root of 2. Okay, and then all of this is divided by 2. Okay, so all I've done, I went to the numerator under the radical and I got a common denominator. Okay, but remember the denominator is also a fraction. This is 2 over 1. Okay, so I'm dividing fractions underneath the square root. So all I have to do is change division to multiplication and flip the bottom fraction. Okay, so this is going to be 2 minus the square root of 2 over 2, okay, times 1 over 2. Okay, so now we can multiply the fractions underneath. Okay, so 1 times anything, if you just multiply across the top and across the bottom, 1 times anything is itself, so we're going to get 2 minus the square root of 2 over 2 times 2 is 4. Okay, we need to simplify this because you have a radical in the bottom. Okay, this is, if you have the square root of a fraction, you can break it up into the square root of the top over the square root of the bottom. And luckily, we know the square root of 4. Okay, so this is going to be the square root of 2 minus the square root of 2 all over the square root of 4 is 2. Okay, this is the final answer. It looks totally crazy, okay, because you have a square root within a square root, okay, but this is what the answer is. Okay, how do I know when to stop? Okay, well, I have an exact answer and my denominator is rationalized. The reason I kept going is because I needed to combine all the fractions into one and I needed to rationalize the denominator. Okay, we can check ourselves. Okay, so what we can do is plug in this value we just calculated and compare its decimal expansion to the sine of 22.5 degrees, and they should be the same. Okay, so if I go to my calculator, I'm already in degree mode, so I'm going to punch in the sine of 22.5. There's the decimal expansion. Okay, and now I'm going to plug in what I got. Okay, be careful with parentheses here because there's a lot of square roots. All right, so if I punch this in, I am going to get, I'll put the numerator in parentheses. So square root of 2 minus the square root of 2. All right, let me make sure that is right. And then I'm just going to divide that by 2. Same decimal expansion. So I know I have the correct exact value of the sine of 22.5 degrees. All right, let's try another one.